Hello and welcome to SudoKanard. In this video, I'll be attempting to solve this corner edge Sudoku puzzle, which was created by Japanese constructor Yosuke Imai and was featured on round 1 of WPF Sudoku Grand Prix of 2022. It was worth 78 points, which is quite high, and I remember it being a tricky puzzle. I managed to find real breakings into the puzzle and then to just fail by breaking the puzzle, by making mistakes, which is usual with me. So the rule. These are corner edge pencil marks. C meaning corner, and that means that 3 and 9 must appear in 2 of those 3 cells, which puts a 3 right from the get-go. And 2, 6, 8 must be in the edge cells, which are those cells. And that's it. So it puts constraints on the positions of digits. So this 4, for example, must be in one of those 3 cells. And up there, the 4 and the 4 must be in those 3 cells, and the 8 must be in those 3 cells. That's what it says. Well, shall we look? So by Sudoku, I get a 1 here or there, and I get an 8 here or there. Let's just do some Sudoku. Those 3s. Now, say that there's a 3 here. But 3 has to be in an edge cell, so 3 is here. And 7 is also on an edge cell, so it has to be here or here. So it can't be here, but 7 here is in an edge cell, so it has to be in one of those 2 positions. And 7 also interacts here with this screw. So 7 is in one of those 2 edge cells. So it's not here, and it interacts with this screw, so 7 has to be here or there. And I think that's all for 7s right now. 3 has to be an edge cell in this region, so it has to be here. Same here. And that's it with 3s. I was looking at edge cells, but what about 2, 6, 8? They still have 4 positions. That's not very interesting, I think. But 2 here is in the corners, here or there. And using this 2, we get a 2 in one of those 2 places, in one of those 3 places. And 6 still has 3 options. And the interesting part is that 6 in this box has 3 options as well. And the interesting part is that 6 does not appear here. So on this row, 6 must be somewhere there. And what's interesting here is that those 4 digits are restricted to 5 cells. And conversely, the remaining 4 cells must contain odd digits. And this one can't contain a 1, a 3, or a 5, so it has to be 7 or 9. And similarly, this has to be 5, 7, or 9. But there has to be an odd digit in one of those 5 cells. Let's move on with corner cells. Those 4 cells must contain an 8 somewhere, but it's not here. So I get an 8 in one of those 2. And using this 8, there has to be an 8 somewhere here, which is not so useful for the time being. 2 is in a corner. So 2 is not here. And we already know that 2 is not here. So we get a 2 in one of those cells. We get a 4 in one of the corners here. There's a 4 somewhere here. Not sure what to do with that. There's a 5 in one corner here. So 5 here, here, or there. Up there, there's also a 5. It's not here, so 5 has to be here or there. Oh, and that's interesting, because there again, we can't have a 5 here. So 5 has to appear somewhere here. And it's starting to be really cluttered. But the interesting part is that now those 5 cells must contain those 5 digits. And 5 is not here anymore. So that's a 7-9 pair. And we see that 1 and 3 must be in those 2 cells. So we get a 1-3 pair. And the other interesting stuff is that only 4 can go here. And then only 8 can go here. So we can remove 4 and 8 from this. Sorry. And we can remove 8 from that. So we have plainly a 2, 5, 6 triple in those positions. And this 4 now bounces back. It removes 4 from those cells. It removes also 8 from this cell. Oh, sorry. So now 4 must go here and 8 must go there. Nice. And using 8s, we must have 8 somewhere here, but we know from this clue that 8 has to be in an edge cell, so 8 is here. So this is not an 8, and that is an 8. And we get an 8 up there. But this clue says that 8 has to be in the corner, so it has to be here. And using all the 8s here, we can put, oh, actually this 8 eliminates this option. 8 has to go here, and 8 has to go here by playing Sudoku. This 4 here now must be in one of those 2 places, and we see that 2, 7, and 4 have to go into those 3 cells. So it's 2, 4, 7 triple. Oh, sorry. So what has happened? This is 2 or 7. I just remove the small pencil marks. Those 2 cells now must be 5 and 6. There's a 5 here, so this is 6, this is 5. I can remove 6 from this cell. There has to be a 6 here or there. There's a 6 here, so we must have a 6 somewhere here. This is some real progress, I guess. What next? This column still needs 2, 5, and 6, but this here can't be 2 or 6 because 2 and 6 must be in edge cells. Oh, actually 2 and 6 must be here. We get a 2, 6 pair here, so it removes 1 from this position, and this is 1. And this now can only be a 5, and the 2, 6 pair is here. 5 must be in a corner cell. So there's a 5 here. And this now is no more a 5. So we get a 2, 6 pair, and those can't be a 6. And there has to be a 6 in the corner, so this is a 6. That's a 2, that's a 6, that's a 2, that's a 6. This 2 bounces back to produce a 4 here. This is 5, 6, 7 triple, and we get 2, 4, 9 triple here. So this is 2 or 9. Those are 2, 4, or 9. here we have a 7-9 pair, but we know that 7 must be in the corner, so this is 9. No, 9 has to be in the corner, sorry. So that's a 7. This is a 2, this is a 7, this is a 9, and we can remove 9 from those cells. Down there, 5 and 7. And here, that's 2, 3, and 9. I don't think I have any constraint on those right now. Here I see that those sevens prevents this from being a 7. Something I could have noticed right from the start is that those edge digits, 1, 4, and 9, form a triple in those three positions. And now this one can't be a 9, so it's 1 or 4. And the remaining 4 cells must be 3, 7, 5, and 6. 3 is not here. 3, 5, and 6 must be in the corner, so this is 3 or 7. But we know that 7 is not here, so that's a 3 actually. So those are not places for a 3. We put a 3 here. Let's remove it from here. This is no more a 3. So 3 is in one of those positions. Four and 2 must be in corners. That doesn't seem to help. There's a 5 somewhere here, so this is not a 5. That's not a huge elimination. Oh, this has to be a 5. This row still needs 1, 4, 7, 9. So this is 4 or 7. It still has 4 options. Oh no, one of them here is a 9. Those 3 cells must be 5, 6, and 7. But this one is not a 5, so it's 6 or 7. 5, 6, 7 here. 5, 6, 7 here. Right. And we get a 5, 6, 7 triple. Oh, and this one is not possible here. So we get a 5, 6, 7 triple. So this here is not a 5. We get a 5 in this column, so I can remove 5 from this cell. We get a 6, 7 pair in this box, so that's a 5. That is not a 5. I can put a 5 in the central cell of the grid. This now has to be 2, 4, or 9, but I know that 9 is on a corner, is on an edge cell. Oh, it can only go there. So that's not a 9, that here is a 9, and this is now 2 or 4. This 9 here makes this a 2, that's not a 2. I get a 6, 7 pair here, and the column still needs 1, 4, and 5. One of them is a 5. This row now still needs 1, 5, 6, and 7. So this is not a 5, it's not a 7, so it's 1 or 6. 1, 5, 6, or 7. Oh, this can only be a 7. And that's a 4, that's a 7, that's a 1, that's a 4, that's a 2, that's a 4. So this is not a 1. And this now is a 2. And we have... This can't be a 1, so it's a 6 or a 7. This is 1, 6, or 7. the third column still needs 2 and 3. This is not a 3 because there's a 3 here. So that's the 2. That's the 3. Pushes the 2 here and the 6 there. That resolves the 7, 6 pairs. And it puts a 7 here and a 9 there. This 3 here makes this a 1, this a 3. I put a 9 here and a 1 there. This is no more 7. I still need a 4 in one corner. This is 1, 4, and 9. So this can only be a 1. There's a 4 and 9 and a 9 on the row. That now is a 6. That's a 7. That's a 1. This can only be a 5. I need a 3 and a 6. There's a 6 in this row, so this has to be a 3. That's a 6. That's a 3. That's a 9. That's a 4. That's a 9. That's a 5. That's a 4. That's a 7. That's a 5. Ta-da! And this finishes the solve of this very well put puzzle. It starts really tricky, but once you see how the eliminations go, the clues interact very nicely with one another. And I think that's it. So thanks for watching this video and see you soon on SudoKanard.